All right, we got an application now for all of these matrix things that we've been doing that's pretty interesting and unique and fun to do. And it happens in chemistry. So in chemistry, one of the things that you have to do is balance equations. So what this really means is, so here's a molecule of, I'm sure this has a name, sodium, 2 hydrogens, dihydride, potassium oxide, or something like that. Well, if you apply some heat to that, or you shake it up, or you do something to that in chemistry, it will split apart into these two things. That actually is supposed to be a capital O right there for oxygen. Okay, so it'll split into a sodium, which is just a sodium, 1 potassium, and 3 oxygens, and then 2 hydrogens and an oxygen. Well, in order for it to do that, there has to be the same amount of elements over here as there are over here. So for example, see right here there's 1 sodium there and there's 1 sodium there. That has to be the same for everything. So it's called balancing chemical equations. Any chemical engineer, anything you do in chemistry, even a first-year college chemistry class, you have to be able to do this really, really well. Well, here's the strategy by hand. I'm going to put a little line there. It's kind of like a mathematical equation, and I'm going to put sodium right on top of it, so you do the same. I'm just going to count how many there are over here. So even though these would be connected together as one big molecule, we can still count the elements. So there's 1 sodium there, so I'm going to put a 1 on this side, and there's 1 sodium there. I'm going to put that on that side. The sodium is balanced. That's how we want it. Okay, then I'm going to put, I guess hydrogen comes next. It doesn't matter which order we do these two. What that little 2 means right there, it means that there's 2 hydrogens on that side. So the subscript means there's 2 of them. So what that would look like is there would be a sodium element and then a couple hydrogens on it like that. Okay, so it's a sodium and 2 hydrogens, and then there's a potassium and an oxygen. So who knows what it looks like, but it looks something like that. So there's 2 of them over here. Well, if we come and look over here, we've got water. So this thing will split into whatever this is plus a little bit of water. Well, H2O, there's 2 of them over there also. So the hydrogens are balanced. And now if I look at the potassiums, there's 1 there and there's 1 there. So as far as potassiums are concerned, there's 1 on the left, 1 on the right. Those are balanced. And then right there's an oxygen and there's an oxygen. So the oxygens are balanced. This one is done. There's nothing to do for this one. One group of this whole big molecule thing will split into these 2 different molecules. Okay, let's take a look at number 2. So this is as easy as it gets. These first ones I'm doing for you is just so you can see how what the numbers and letters all mean. So here, I'm going to start with this hydrogen. Okay, there's 2 hydrogens, and right there's 2 hydrogens. So I've got 2 hydrogens on this side and 2 hydrogens on that side. Okay, right there's a carbon, and over here there's 1 carbon. So carbons are 1 and 1. They are also in balance. And then there's 3 oxygens. So on the left there's 3 oxygens. Here's 1 oxygen, and there's 2 more. So there's 1 here and 2 more there. So the oxygens have 3. This one's balanced. It's already done. Okay, let's look at number 3. This has a little bit different notation to show you. Ca, I'm not sure what that is. Ca, there's 1 over here and there's 1 over here, balanced. Okay, here's some oxygen. There's an oxygen and there's an oxygen for a grand total of 2. So there's got to be 2 on this side. Well, now what this means when they have parentheses like that, that's its own little, so this would be like a Ca, and then there's an O with an H on it, and then there's 2 of them. So this OH is kind of like its own thing twice. Well, that means there's 2 oxygens, 1 there and 1 there. And it means there's 2 hydrogens, 1 there and 1 there. So the hydrogens also on this side have 2, but on this side it also has 2. This one's in balance. But that's what this subscript means here. It means there's 2 O's and 2 H's. That's what it will mean on this side also. 2 O's and 2 H's. So there's a BE. There's one there and one there. 1 and 1. So that's good. For oxygens, there's 2 oxygens on this side, and then there's 1 and 1. So there's 2 on the right and 2 on the left. And then here we got 2 hydrogens and 2 hydrogens. So that one is also good. Okay, let's see, one more that's already balanced. Number 5 should already be balanced also. So here I've got a lithium twice. Okay, so we don't have, this one's not balanced. Now here's the first one that's not ready to go. So lithium, right there's 2, but over here's only 1. So this one is not in balance yet, so we're gonna have to do something with that. Okay, let's take a look at oxygens come next. So there's 1, 2 oxygens. So on this side I've got 2 oxygens, on this side I only have 1. Okay, what about hydrogens? Okay, right there I've got hydrogens. There's 2 hydrogens over here, but only 1 over here. Okay, so it looks like this whole side all needs to be doubled in order for that to be balanced. So if I were to put a 2 up here, so if you put it in the front, it's kind of like in algebra. If you put it in front, it means you've got 2 of this whole thing. So now what that means is I've got 2 lithiums, I've got 2 oxygens, and I've got 2 hydrogens, and now the whole thing is balanced. So the way we write these is, okay, we need a lithium 2O, whatever, that's probably got a name, plus water. We'll split it, we'll turn itself into 2 of these LiOHs. So if you dump a bucket of this in with a bucket of water, you'll get 2 units of whatever this stuff is. That's what it means to balance an equation. All right, let's try that on this one. So this one was pretty easy. This would be considered a really easy one because all you had to do was double this side. Well, let's take a look at this one over here. Let's start with sodium. I've got 2 of them over here. There's 2 of them, but 4 of them over here. So that's certainly looks like a double situation. Hydrogens. There's a hydrogen, and there's 2 hydrogens. Okay, so I got 1 over here and 2 over here. So far it looks like, so far it looks like this one needs to be doubled. Okay, there's a P, potassium, and there's 2 of them. So for P's, there's 1 over here and 2 over here. And then for oxygens, okay, it looks like I got 4 over here, and there's 7 of them over here. I'm sure there's a typo. This should be H2O. Let's put an extra O on there. Or by the time I get to yours, yours will be fixed. And there's the one there, so there's 8 of them. Okay, so reasonably easy. This side just all needs to be doubled. So if we put a 2 in front of that up there, now I've got, so let's take a look at what this means now. I've got 2 Na2s. So I've got a Na, but now I have 2 of them. So now there's 4 there. So I've got 2 of that thing. I've got 2 of these H's, so it's going to double that. I've got 2 of the P's, so it's going to double that. And I've got 2 of these O4s, so it's going to make it 8 of them. So number 6 simply needs a 2 on this side. So if you've got 2 of these things, it'll split itself into 1 of these and 1 of water. All right, number 7. So we're doing these by hand. As they get more difficult, we're going to need some help. Okay, so I got Fe, I got 2 Fe's over here. I think that's iron. And I've got 2 over here. I'll do oxygen next. There's 3 and there's 2 more, so there's 5 oxygens on the left, but there's 7 on the right. Okay, so now here's the first one where we're not going to have just an obvious double up. Okay, what should we look at next? Si. Looks like I've got 1 Si on this side and 2 Si on that side. Okay, So it looks like the Si needs to get doubled, but this oxygen, I got to go from 5 to 7. Sometimes that's a tough thing. So now we come up here and look at this. Okay, here's the only place where there's Si. That certainly has to get doubled. If I were to put a 2 there in front of all of that, just on this one, I'm only going to double this one. That does now make 2 SIs. So I have that done. I didn't affect the FEs because I didn't put anything out here. So that doubled the SI, but it also doubled the O2s. So now this side, this piece now has 2 O2s. So there's 4 of them sitting there and 3 more there, which ends up making it 7. And now we have the whole thing balanced. So this time, 1 unit of this plus 2 units of this will go together to make this compound. That's balancing equations. Okay, let's take a look at number 8. See if they get any more difficult. Okay, well let's see what we've got here. I've got a Ca. There's 1. Oh, so capital letters are different elements. So small letters are just part of this one. So that's not 2 different things. Ca is, I should know what that is, but I can't remember. Palladium or something. And then S is sulfur. So capital letters are individual elements. Okay, so I've got 1 Ca on that side, and I've got 1 on this side. So it's 1 to 1. There's an S. I got 1 sulfur, and over here I got 1 sulfur. What comes next? Here's some H2Os. So this water. So I've got a hydrogen on this side for 2. And now here's this combo thing again. So there's 2 hydrogens and 2 oxygens. So there's 2 hydrogens and there's 2 more hydrogens. So this side has 4 hydrogens. And then let's take a look at oxygen. Here's 1 oxygen and here's 2 oxygens. So those 2 look balanced. So it looks like this CAS I probably don't want to touch that one. But this H and O's needs to be doubled. So I need twice as many over here of this H and O. Well, look, I've got some H and O's right there. If I double that piece, now I've got twice H2s. So now I've got 4, which is exactly what I needed, and 2 oxygens, which is exactly what I needed. So 1 of these and 2 units of water will recombine with 1 of these and 1 of these. Okay, let's look at 9. That one looks like a real easy one. Well, let's take a look here. There's 1 carbon on this side and 1 carbon on that side. It's already half done. There's only 1 more thing to do, oxygens. Okay, well there's 1 there and 2 there, so there's a grand total of 3 on this side, but there's only 2 on this side. Okay, sometimes that becomes a little bit of an issue. How to leave this alone but make these better. Well, let's see here. Maybe we look at some kind of common denominator. What about right here? What if I go for the oxygens first, right there? This side's got 3, this side's only got 2. Maybe I'll go, see if I start to, if I double this one, that'll bring this up to 4, because there's 2 there and now 2 there. But it brings the carbons up to 2, so it kind of fixed this one because I can double this one to get 4, but it's going to ruin that one. So I'll try doubling this one. I'll stay with it right now. Okay, putting a 2 there. That puts, what do I have here? That puts 4 over here, and 2 carbons, 2 there. Okay, did we get it balanced by putting a 2 there and a 2 there? Carbons 2, oxygens 2, 3, 4, oxygens 4. Looks like we have it balanced. So we need 2 of these plus 1 of those will go to 2 of these. Okay, what about 10? One more. Well, there's several more, but one more that we'll try as they get a little bit harder. Okay, chlorine, that's a small L. Okay, there's one chlorine and one chlorine and one chlorine over there. So it looks like that starts out as 1 against 2. Okay, what about oxygen? I'm not sure I have this one written down right. Let's take a look here. Oxygen's 2 and 1 is 3. 2 and 3 is 5. Okay, hydrogens. We've got 2 over here, and 1 there and 1 there, so that's a 2 to 2. So it's really just the oxygens that I need to try to deal with. Oh no, and the chlorines. So I need the chlorines to get doubled, so how about I double that one and see what happens. Okay, there's 2 chlorines. That makes that one work. That makes 4 oxygens plus this one right here is 5. Okay, so that did it. So there we have it balanced. I need 2 of these elements plus water can combine to make those 2. Okay, what about 11? This one looks easy. AS, whatever that is. Okay, it looks like I've got 2 of them. And over on this side, I've got 1 of them. Oxygens. There's 5 plus 1 more for 6. Over here, there's 4. Okay, hydrogens. There's 2, but there's 3. Okay, now I need to start maybe trying to, let's see what we can do here. And the AS is, this one has to at least be doubled in order for these to work. So I'm going to think about putting a 2 there. So if I put a 2 there, that makes 2, and it makes 2 times, there's 3 hydrogens twice, so that's going to make 6 over here of those. And I've got 4 oxygens twice, it's going to make those 8. Okay, that balanced the AS, but we still don't have these balanced. So now these over here are short. Maybe I'll look at the hydrogens. I need to triple the hydrogens. Okay, well, that's only right here. So what if I squeeze a 3 in there? Okay, now I've got 3 sets of 2, so there's 6 hydrogens, that's good. Now that makes 3 oxygens. And then I had 5 oxygens over there, so I've got it up to 8. Okay, so we have that one balanced. It took a little bit more. There's 3 of these, and 2 of these, and 1 of these. Okay, as these get more and more difficult, it would be nice if we had a way to do this in a math kind of a way. So I want to try to show you that. Let's do it on this one first. Let me rewrite it. Let's say AS2O5 plus H2O. How many of those will make how many of these? Okay, that was the original problem. What I want to think about this is, I want to think of it as an equation. I'm going to basically bring that to this side and make it look like this. AS2O5 plus H2O. Bring this over here as a H3ASO4 and let it equal 0. Now it's like in an equation. And I want to set this up in a matrix. Okay, I'll put the matrix right here. But here's what the matrix is going to look like. I'm going to call like this the A term, this the B term, and this the C term. So it's like AX plus BY plus, it's something A plus something B plus something C. It's kind of like this. I'll call this XYZ. It's like something X plus something Y plus something Z equals 0. It's kind of like that. The A is the first piece, the B is the second piece, the C is the third piece. But in my matrix, I'm going to count up just the AS's. Okay, so I'm going to put a little AS there. When I go look at it right here, so I'm going to do it for each term. I'm going to write it again up here so that oops, that's not it. It was AS2O5 plus H2O minus H3ASO4 equals 0. Okay, so this piece right here, I see that there's 2 AS's in that piece. I see there are 0 in that piece. I see there are, what was that? There's 1 in that piece, and it equals 0. Okay, that's the matrix row for the AS. Now I'm going to do a row for the oxygens. Okay, there were 5 oxygens in this piece. There's 1 oxygen in this piece. There's 4 oxygens in this piece, and it all equals 0. Okay, then I'm going to do similar something for hydrogens. There are 0 hydrogens in this piece. There are 2 hydrogens in this piece, and there were 3 hydrogens in this piece, and there were 0. So I guess now there was a negative in front of that. I'll address that in a minute. Let's go ahead and put negatives on all of those. Okay. I have a matrix. I have a 1, 2, 3 by 1, 2, 3, 4. I have a 3 by 4 matrix. Okay, I'm going to put that in my calculator. Second matrix, going to edit, make it a 3 by 4. So I have a 2, 0, negative 1, 0, 5, 1, negative 4, 0, 0, 2, negative 3, 0. There's the matrix. What I would like it to look like is the identity matrix. I would like to get all 1s down here so the last column is the answer. Okay, well let's make it do that. The calculator can do that really quickly. The reduced row echelon form is right there of matrix A. Okay, so there it is. I'm going to jot that down. So I've got 1, 0, was negative half, 0. Then I had 0, 1, negative 3 halves, 0, and then I had 0, 0, 0, 0. That's what the calculator had. Okay, right here's the reduced row echelon part. There's the diagonal that we're looking for. Now remember what these were. This was the A, this was the B, and this was the C. So what this one is saying is A plus 0B minus a half C equals 0. So I have A minus 1/2 C equals 0. That's what that one is saying right there. And then the next one is B minus 3/2 C equals 0. So look what we have. We have everything in terms of C. I'll put this over. I'm kind of running out of paper. So I'll put it right here. My A, if I just move the half C to the other side, that first term is 1/2 C. If I move this to the other side, the second term was 3/2 C, and then I can just pick C. It's like what we were doing in the last one with the, all the unlimited infinite solutions. This is the relationship. Well, I would like it to be a whole number relationship. Look what happens if I pick C to be 2. These fractions will cancel out. So I'm going to pick C equals 2. Okay, well, if I put a 2 right there, 1/2 times 2 is 1. 3/2 times 2 is 3. And then I picked 2. Look what that is. 1 is the coefficient in front of the first one. 3 is the one that solved the second one. And 2 is the one that solved the third one. And we can confirm that like this. Okay, so let's practice that on number 12. So I'm just going to go straight to a matrix. Now, technically, I would have moved this one to the other side and this one to the other side, and it would have been equal to 0. Okay, so I'm not going to actually move them though. So let's take a look at, let's see what we can do here. So I've got a chlorine. Okay, so right here I've got 1. Right here I've got 0. This would have been on the other side, so that would be -1 chlorine. And this would have been on the other side, that would be -1 chlorine. And it's all going to equal 0. Okay, how about oxygens? This one has 2. This one has 1. This one on the other side would have -2. This one on the other side would have -3, and it all equals 0. Then I've got hydrogens. You've got to have a row for every single element. So this piece has 0 hydrogens. This piece has 2. This piece, if it was on the other side, would have -1. This piece on the other side would have -1 and adds up to 0. So we've already done oxygen, so that's all of them. 1, 2, 3 by 1, 2, 3, 4, 5. So I've got a 3 by 5 to put in my calculator. Okay, so it's 1, 0, -1, -1, 0, 2, 1, -2, -3, 0, 2, -1, -1, and 0. Okay, I would like it in reduced row echelon form. Oops. Matrix math, come down a little bit, row echelon form of matrix A. Okay, let's see what we have here. So what I have is 1, 0, 0, 0, 0, 0, 1, 0, -1, 0, 0, 0, 1, 1, 0. Okay, so this was up here. This would have been my A, B, C, D, and answer. So A, B, C, D, and answers. All right, so let's take a look at what this one is. This one says C plus D equals 0. This one says B minus D equals 0. This one says, what does that one say? That one says A equals 0. That's not good. Because we want to have an A term, where you can't just have no A term. Okay, I'm actually kind of glad that happened because it illustrates a point of what's going on here. We can't have A equals 0. That doesn't make any sense. That means this is gone. So H2O, one bucket of water, cannot split into those two things. So there's clearly something wrong here. Either this reaction cannot happen, that could be what that means, or we made a mistake somewhere. We made a mistake counting up the oxygens, or we made some other kind of a mistake. Okay, let me show you where the mistake is. I read that as chlorine, that as a Cl. I thought that was a capital C and a lowercase l. But that's a capital I. Those are two separate elements there. That's chlorine and that's iodine. So when I make this matrix, let's make it again here. So I've got, that's carbon and that's iodine. So here, for carbon, there's 1 carbon, 0 carbons, -1 carbon there, because if I were to move that over, and -1 carbon there is 0. Then I'm going to do iodine. There's 1 iodine, 0 there. There's -1 iodine there, and there's -1 there. Now I'm going to do oxygen. So oxygen, there's 2. Oxygen, there's 1. If I were to move that over, there would be -2 oxygens here, and there's -3 oxygens there. And then we've got hydrogen. No hydrogen, 2 hydrogen, -1 hydrogen, -1 hydrogen, and 0. Okay, let's put that in. Now we've got a 1, 2, 3, 4 by 1, 2, 3, 4, 5. We've got a 4 by 5. Let me put that in my calculator. A 4 by 5, so I need 1, 0, -1, -1, 0, 1, 0, -1, -1, 0, 2, 1, -2, -3, 0, 0, 2, -1, -1, 0. Okay, let's run that one. Let's get the refined row echelon of the reduced row echelon of that. Okay, so I'm going to write down what I've got here. So now I've got 1, 0, 0, -2, 0, 1, 0, -1, 0, 0, 1, -1, and 0, 0, 0, 0, 0. Now this is okay. That one just eliminated to make this diagonal right there. So this was A, B, C, D, and the answers. Okay, so look what we've got right there. We've got C minus D equals 0. Right here, I've got B minus D equals 0. And right here, I've got A minus 2D equals 0. Okay, so putting that in order, solve this one for A, so I'll move the 2D over. So that's the A spot. The B spot, I'll move the D over. The C spot, I'll move the D over, and then D is just sitting there. Okay, let's take a look and see what we have. I'll just let, these are all whole numbers, so D can be 1. Okay, so now let's see if that doesn't balance it. So what I'm saying is we need 2 CiO2s plus 1 H2O. That will give us 1 HCiO2 and 1 HCiO3. That's putting these constants in front, and now let's make sure and see that it's balanced. Carbons, there's 2 carbons over here, 1, 2 over here. The carbons are balanced. Iodine, there's 1, there's 2 of them, sorry. There's 2 of those iodines, there's 1 and there's 1. So we've got 2 against 2 there. Oxygens, there's 4 plus 1 is 5. So over here there's 2 plus 3 is 5. The oxygens are balanced. And hydrogen, there's 2 on this side and there's 1, 2 on that side. We have it balanced.